In 1687, Sir Isaac Newton came up with the equations of universal gravitation, where the force of gravity is equal to the gravitational constant times the product of the two masses divided by the distance between them squared. By substituting in accepted values for the gravitational constant, electron, proton, and the radius of the hydrogen atom, we have a force of gravity equal to 3.63 times 10 to the power of minus 47 newtons attractive between the proton and the electron. In 1787, Charles Augustin de Coulomb developed the equations for electrostatic force, which is similar to the Newton's equations. Again, if we substitute in accepted values, we end up with a force of charge of 8.22 times 10 to the power of minus 8 newtons attractive between the proton and the electron. It's no wonder that with these two equations so similar, in 1913 Niels Bohr came up with this planetary model. If we do a ratio of Coulomb's force over Newton's force, we have a difference of 2.26 times 10 to the power of 39. That's over 2 followed by 39 zeros more powerful. Despite the similarities, Bohr's planetary model of hydrogen had a few problems. It could not explain why only certain atomic orbits were permitted, and that they were spherical when the universe had no restrictions on radii and bodies orbited on stable, predictable planes. But the major problem was magnetism. Unlike mass, gravity, and charge, which are properties of matter, a magnetic field is a product of a moving charge. It transmits energy, and it requires energy to be produced. Those astute will recognize it's actually the counter EMF that causes the resistance. And the counter EMF comes from the only other charge in the atom, the spinning nucleus. To put it simply, the speed of the orbiting electron of a hydrogen atom creates a magnetic field, which requires energy. This energy is taken from the electron's kinetic energy, reducing its speed. In order to recover its kinetic energy, the electron drops its orbit, converting some potential energy back into kinetic, increasing its speed, creating more magnetic field, requiring more energy. The inevitable conclusion is that this electron spirals inward and collides with a proton, creating a neutron. In 1924, Schrödinger came up with his electron cloud theory with the wave-particle duality. While it did seem to duplicate what they were seeing, it still didn't address any of the issues. Since a non-moving particle wave electron didn't create a magnetic field, its orbit wouldn't decay. However, what is the source of a magnetic field, which obviously does exist, and still no explanation as to spherical orbits with stable radii? The Heisenberg uncertainty principle was conceived to support the Schrödinger theory and to explain why consecutive electron observations resulted in random locations. Although largely considered obsolete in the majority of science, the Bohr's model is still taught in chemistry and electrical classes, where discrete electrons are required. In 1961, the electron single and double slit experiments seemed to support the wave-particle duality. So let's do an actual comparison to electron wave particle to a water wave. For a single slit in a water tank, the waves continually oscillate between the maximum and minimum values. The height of the maximum and minimum are determined by the inverse square of the distance the wave traveled to the screen. The wave gives the illusion of moving outward. A single slit in the electron experiment, the height is determined by the number of strikes per equal spacing, and it falls off far faster than the inverse square of the distance traveled, which is typically 1 meter. And there is no oscillation with the electrons. This is the first indication that it isn't a wave. However, if Bohr's model is accepted, then the orbiting electron traveling at 0.75% the maximum speed of light would appear to be almost standing still compared to a free electron traveling at 10% the speed of light. This would be the equivalent of you walking in a circle around your front yard at 4 kilometers an hour, while a car speeds by on the street at 55 kilometers an hour. If you were walking beside the sidewalk, location A, as the car drove by, your negative influence as an orbiting electron would repel the car's negative charge as a free electron. Your deflection would be stabilized by the nucleus, while the car would be deflected slightly to the left. Later, if you were beside the house, location C, at the time another car came by, the positive charge of the proton in the middle of your front yard would attract the negative charge of the car, thus deflecting it slightly to the right. And when you're halfway between the sidewalk and the house, locations B and D, perpendicular to the road, the car would experience both your negative influence and the proton's positive influence, and thus continue straight. So depending where you were on your walk would determine the deflection of the car, creating a normal curve on the display screen when compared in number of impacts to location. And this is what we observe with the electron single slit experiment. For the double slit in the water tank, the waves slit interfere with each other, creating nodes. Negative interference, non-moving locations where the maximum crest of the one meets the minimum value of the other, and peaks, positive interference, where the two crests meet and the two valleys meet, oscillating back and forth. The double slit experiment have nodes, zero impacts, between normal curves for impacts, but again, no oscillations. The biggest difference in the double slit's single source were the water tank. The biggest difference is the double slit single source. For the water tank, the results are the same as the single slit. However, for the electron experiment, it is similar to the interference of the double slit. How can there be interference when there is no electrons coming from the second slit to interfere with? The only difference between the two experiments is a tiny sliver of copper between the two slits. So if the question is, what looks like a wave interference pattern but isn't, any engineer will point to galloping Gertie and tell you it's a resonance pattern. For those of you who have access to the equipment to do a electron double slit experiment, do the following test. Shoot a stream of electrons through the left slit, and you should result with the blue locations. The right slit should have the mirrored image, which is the peak over by the same distance as the center-to-center distance between the slits, resulting in a series of red locations. Shooting electrons through both should result in the black lines. Of course, my diagrams are crude. In a future video, I will explain the dynamics of this resonance. Meanwhile, let's apply the maximum speed of light to the velocity of charge and magnetism on the Bohr Planetary Model.